Hi everyone, welcome to
amazing channel of Brilliant Katha.
When you are rubbing one body with another body, electrons are transferred from one object to another object. Okay, this process, this type of electricity is been given a name.
connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Katha.
Hello my dear students, welcome back to another live session of chemistry. Let us wait for a few minutes for others to join. Hurry up my dear students, join fast. Yes, people are joining. Yes, Atul, Matthew, hi. Hisham, Flip Flops, hi. Good evening, Hisham. Yes, Shiny Sabu, good evening. Babida, hi. Yes, dear students, join fast. Let us start our session. Shyam Kumar, yes, Chris, good evening. Hanna, good evening. Shyam Kumar, good evening. The session is going to start. Aspects, yes. Good evening. Yes, now we can start. Dear students, hope you all have prepared a timetable to plan your studies. Keep up the hard working and keep practicing all the previous year questions. As you know, most of the question patterns are repeated. So this year also we can expect the same pattern of question. So try your level best this time, all the very best. Now we can start our session. We don't have time in our hand to waste. So we will go for the session. Today we are going to discuss two chapters. One is D and F block elements and the second one is amines from organic chapter. See, both the chapter has equal weightage and you can expect few MCQs and assertion reason questions from this chapter. Shall we start? Are you ready? Guys, are you ready? All are there? I need your active participation throughout the session, same as the last three sessions, so we can be interactive. Send your right answer in comment box. Okay, I'll give you time to choose the correct option. So be active. I want your active participation. Yes, Atul. Yes, Satwik. Yes. We are going to start. Okay, now we can move on to the question. Yes, Sri. All are there. So the chapter amines and D and F block elements we are going to start. Question number 1. See, we will do question from amines first. The first question, I think it's the easy one. Yes, all are there. Thank you guys. Be active. We are going to start question number 1. In this reaction, acetamide is converted to methenamine. It's an average question, or we can say it's an easy one. It's based on a name reaction. See, yeah, now the answers are coming. Yes, yes, Atul, Matthew. Yeah, while reading the question itself, people are able to answer it. So, good, good. Keep it up, keep it up. Devan, yes. Shasa, good, good, very good. Yes. Karthik, yeah, options came. See, in this reaction, acetamide is converted to methenamine. We know that one they are asking about. Which one? Acetamide means, you know that one, two carbon atoms are there, it's an amide. 2 carbon containing amide is converted to 1 carbon containing amine. Okay? It's direct one. We know that one, that is talking about which one? Hofmann's bromamide reaction, and it's a degradation reaction. So acetamide, you know that one, acetamide we can write CH3CONH2 when reacts with the Br2, okay, plus KOH. You know that one. Here the reaction takes place like this one. The CO will be removing. Then you know that one, you will be getting CH3NH2. Okay, KOH or NaOH can be used. So you know that one, the byproduct will be getting as KBr plus, no need to write that one anyway, K2CO3 plus H2. You know that one, that name reaction is the most important one from amines. Yes, Aditya, good, good. Chris, Devan, Karthik, Shisa, everyone gave the right answer. Well done, well done. So here amide, acetamide converted to methenamine or methylamine. That the correct reaction is which one? Hofmann's bromamide reaction. Very good. Hofmann's. It's a degradation reaction. Carbon number will be, 1 carbon will be less than the parent compound participating. So it's a degradation reaction. It's important for descriptive as well. Thank you all. Thank you all. Yes, Sanj Shyam Kumar, good, good. All gave the right answer. We will move on to the question number 2. Second question. Read the question carefully. Next one, the most basic compound. You know that one, based on basicity, boiling point. You can expect a few questions from amines. Basicity in gas phase, basicity in aqueous solution. Okay, and the boiling point of amines, that all they will ask. Yes, I think answers are coming. Yes, all are there. Yes, very good, very good. Send the answer. The most basic compound among the following is, read the question, acetanilide. You know what is acetanilide? Benzylamine, para-nitroaniline and aniline. See, we have few idea about the basicity. That concept is nothing but all aliphatic amines are, you know that one, right? All aliphatic amines. Aliphatic amines are more basic than ammonia. Okay, and the aromatic amines come, RNH2. Aromatic amines are less basic than ammonia. That is the basic idea about the basicity of amines. You know that one. Aliphatic amines wherever comes, they are the most basic. Among aliphatic amines, you know that one, tertiary greater than, secondary greater than primary. That we will discuss later. Here you keep in mind. But few compounds are there other than amines. That I will explain. You know that one, acetanilide. Acetanilide, we know that one. Acetanilide can be, draw the structure like this one. You know that one, NHCOCH3. Okay, NHCOCH3. Anyway, you know that one, this one we learned. The NH2 group is protected in aniline by acetylation. Acetylation means we will be introducing CH3CO group. How it can be, make it as deactivated, we are learning. This one is deactivating by, you know that one, the lone pair on nitrogen will not undergo resonance with the benzene ring. Instead, it will undergo resonance with the CO. Which means there is C double bond O, the lone pair will be interacting with the resonance of C double bond O, and it is not available for the resonance with the conjugate system or the benzene ring. So it will be less basic, okay, less basic than aniline, because that lone pair is not available for protonation. Anyway, whether it is with the benzene ring or CO, that lone pair is not available for protonation, means less basic, no doubt. But we have one aliphatic amine. What is the aliphatic amine? You know that one, that is benzylamine. What is benzylamine? Benzylamine is benzene ring having CH2NH2. See, here the NH2 group is not directly attached to benzene ring, so the lone pair on nitrogen is easily available for protonation. So whenever it undergo protonation, that is the basic one, because amines are basic due to the presence of lone pair on nitrogen, and it undergo protonation. Yes, very good. It's all, everyone I think gave the right answer. Yes, my dear students, you have good idea. It's so happy to know all these things. Okay, so this one benzylamine, that is an aliphatic amine, comes under aliphatic amines, you keep in mind. Para-nitro, not even, no need to consider even, because you know that one here it is NH2, that is para-nitroaniline. You know that one NO2 group is what? Electron withdrawing group. Electron withdrawing group always decreases the basicity, which means it is less basic than aniline. So aniline is there, nitroaniline is, para-nitroaniline is less basic than aniline, and acetanilide is also less basic. Benzylamine is aliphatic. So correct answer is which one? Benzylamine. So benzylamine is the most basic among this one, because it is an aliphatic one, because NH2 group is not directly attached to benzene ring. Yes, fossil, correct, PSD, yeah, all are there. Now listen, so benzylamine we have, benzylamine, the right answer is benzylamine, since it is aliphatic in nature. So we can move to the next one, third one. See, third one is also based on, read the question carefully. Aniline first reacts with acetyl chloride. You know that one, acetyl chloride is used to convert, okay, that one, or to protect the aniline group or to deactivate, because NH2 group is highly deactivating. If you want mono derivatives, okay, ortho derivative and para derivative separately, then you know that one, that NH2 group first will be deactivated by acetylation. That is the given hint. Aniline first reacts with the acetyl chloride, producing a compound A. Clear? That compound reacts with the concentrated HNO3 and H2SO4, or HNO3 H2SO4 mixture is nothing but nitrating. Nitration is carried out, followed by nitration, and you will get a compound B. Those compound on hydrolysis will give C. You know that one, it's called indirect nitration of aniline. We have two types of nitration. Yes, my dear students, Karthik, you know that one. We have two types of nitration. One is direct nitration of aniline. Second one is indirect nitration. What is indirect nitration? Indirect nitration means nothing but we will take aniline, okay, NH2, that will be first treated with the CH3COCl, acetylation. You know that one, in presence of pyridine. You know that one, that pyridine prevents the backward reaction or reverse reaction. Then you know that one, here the reaction will take place like this one. One HNCl will remove as HCl. Then you will be getting the product like this one. Here it will be NHCOCH3. Before we wrote the same product. Okay, this one, you know that one, this one carried out, this compound is going to undergo nitration, concentrated HNO3 and concentrated H2SO4. Now this NHCOCH3 group is deactivating. Due to the deactivating nature of that group, we will be getting two derivatives, an ortho derivative and a para derivative. NHCOCH3 is here. You will be getting an para derivative, that is the major one. 80% of the mixture will be that para derivative, and the ortho derivative also will be getting, that is NO2 at the ortho position. I think it's visible. Yes, ortho position you will be getting, but only the major one we can consider here, that compound, okay, that I'll draw the para one, that is the major one, because they are talking about only one compound C, which means the major one. So the major one is NHCOCH3, and the para position we have NO2. This one, you know that one, hydrolysis, okay, H3O plus. You know that one, this one, when undergo hydrolysis, here the bond breaks. H plus will come to the left and OH minus will come to the left, right side. H plus will come to the left side. Then you will be getting the product, this one, that the product is benzene ring having, here it is NH2 will come back, the group will come back. Because direct nitration we cannot do, because all the three side you will be getting 2,4,6 trinitro aniline, it will means that all the position, not the combined one, ortho under para and meta, all the mixture will be, all the three derivative will be forming as a mixture. We want the separate. So here will be NH2 and here you will be getting NO2. This is the right answer. So what is the name of this one? Para-nitroaniline. So we are not considering this ortho derivative, because ortho derivative is minor. No need to consider that one. So the major only you consider, that on hydrolysis you will get back the NH2 group and you will be getting para-nitroaniline. Hope you understood. The right answer is C. Let me know who all gave the right one. Yes, Freddy. Yes, yeah, I know the language. Thank you. And Atul Matthew, yes, everyone gave the right one, right answer. Well done, Fasil, all are there. Thank you guys, thank you. We can go to the, move on to the fourth one. Dear students, read the question. Satvik, yeah, correct. Which of the following is formed in the reaction of an aldehyde with the primary amine. See, keep in mind, this question you might have gone through very rarely. Okay, you might have heard about Schiff's base, correct? Because we have the same in our syllabus, it's not out of syllabus. Schiff's base we learned in case of glucose. Glucose does not react with the 2,4-DNP, glucose does not react with the Schiff's base. We have a detailed study of Schiff's base in competitive exam, but I'm not going to explain that in detail. But Schiff's base is given in the as a part of syllabus. Schiff's base means, you know, that whenever aldehyde reacts with the primary amine, even ketone also, but here you keep in mind, aldehyde when reacts with the primary amine, we will be getting a substituted imine or imine, you can say. That substituted imine is actually called Schiff's base. We are learning this one in aldehyde and ketone chapter as well as an addition. So that name you keep in mind. They can give this question as a higher order one, so that's why I selected this one question. See, I'll write the equation. Keep in mind, whenever you take an aldehyde, I'll write the general one. Sorry, aldehyde we can write it as RCHO. You know that one RCHO is RCH double bond O, aldehyde. When reacts with amine, so primary amine means nothing but RNH2. So I'll write this way. It is nothing but it's a removal of water takes place. This H2 and this oxygen will be removing. Then you will be getting a compound like this one RCH. I wrote the inverted manner to easily remove this water. Then you will be getting RCH double bond N single bond R. You know that one, wherever CH double bond N comes, it's called imine or imine. Then R when comes means NH will come, one H again substituted by R, so it is called substituted imine or substituted imine. Okay, plus H2O is the product. See, nothing but, dear students, the substituted imine is called Schiff's base. Okay, keep in mind, this is called Schiff's base. Wherever Schiff's base forms, that means it can be an aldehyde with the primary amine. So, which of the following formed in the reaction of an aldehyde with the primary amine? So, aldehyde, whenever any aldehyde. So, if they are giving the specific one, CH3, CH double bond O, then here if you are taking a methylamine or methenamine, NH2, you know that one, the product formed will be like this one. So, here water will be removing. Then you can write the product. That product will be CH3 CH double bond N single bond CH3 plus H2. Okay, this one, that is N methine will come, that is imine only, that is called the Schiff's base. So just keep in mind, Schiff's base is a product formed when aldehyde reacts with the primary amine. That you keep in mind. Okay, well done Atul. Yeah. So all the, I think the correct answer gave almost all. So correct answer is Schiff's base. Keep in mind, that is an important question. Okay, so question number 5. This on reduction with, so we can move on to the next one, question number 5. This on reduction with the lithium aluminium hydride. Dear students, what is lithium aluminium hydride? What is lithium aluminium hydride? Lithium aluminium hydride is a reducing agent. So lithium aluminium hydride is a reducing agent, produces secondary amine. They are telling that one lithium aluminium hydride, when you are using for a compound, it will give secondary amine. I'll give a logical part over here. You keep in mind, whenever cyanide, okay, I'll write the functional group, that will be better. Cyanide when undergo reduction with the lithium aluminium hydride, keep in mind, dear students, you will be getting primary amine. This is very important. If it is NC, isocyanide with the same reducing agent lithium aluminium hydride, you keep in mind, you will be getting secondary amine. Yes, very good, Satvik. Well done. Yes, reducing agent. Yes, people are giving answer. Good. Yes, Hanna. Yeah, right answer came already. See, this one you keep in mind. It's very important. Wherever NC is what? Isocyanate. Also, what is methyl isocyanate? Methyl isocyanate is CH3NC. When reacts with the lithium aluminium hydride. So I gave the idea. You know that one. Whenever lithium aluminium hydride is there, if you want, you can write 4 hydrogen. Same like the Clemmensen reduction and all. You know that one, here is a triple bond. So among the triple bond, 2 bond will break, 1 hydrogen will go to nitrogen and 3 hydrogen will go to carbon. Then you will be getting the corresponding secondary amine CH3NHCH3. This is the secondary amine you will be getting. So whenever isocyanide reacts with the lithium aluminium hydride, reducing agent, always you will be getting a secondary amine, no doubt. So correct answer is methyl isocyanate. That is the only one isocyanate given in the option. So correct answer is option C. Yes, well done, well done. Yes, good, good. Atul, all are there. Yes, Satvik, well done, well done. So dear students, we will go to the question number 6. Okay, give your right answer, be active. Okay, so read the question number 6. Which of the following does not react with the Hinsberg reagent? Another easy one, but these are all from the previous board question papers. So these level of question you can expect, but be confident and choose the right one, should not make mistake. So whenever you do MCQ and assertion reason, you should take utmost care, and you have to read the question very carefully, then only you can choose the option. Yes, yes, all are giving the right one. You know that one. Here also I will write the statement to remember easily. You know that one, whenever primary amine, okay, reacts with the C6H5SO2Cl, what is that? Benzene sulfonyl chloride, you will get an addition product, right? Addition product. That addition product, so that addition product will dissolve in what? KOH. So we can write soluble. This is the statement for what? Primary amine. Secondary amine, I am not writing this one. You will get addition product, but here I will write KOH, but not soluble. This one only you have to keep in mind. You know how to write the addition product. I am not wasting the time. We need to finish all the questions. So secondary amine I will write, okay, plus this one, okay, then I'll write no reaction. So whenever you take tertiary amine will not react with the benzene sulfonyl chloride or Hinsberg reagent, since there is no replaceable hydrogen in which one? Tertiary amines. So tertiary amine, there is no replaceable hydrogen, or there is no that hydrogen combined with the Cl, then the addition product is forming, but there is no replaceable hydrogen. That all you know. I know that one you have very good idea in amine, so option is C, because since it's a tertiary amine. Yes, almost all gave the right answer. Tertiary amines, absence of hydrogen. Yes, well done, well done. Sanjay, good, good. Yes, Chris, all are there, good, good. So correct answer is C. This one is the statement, always you keep in mind. Question number 7. Yeah, 7th one you do the question, I think it's a complete the A, B, C, D compounds you need to find out. This type of question, even the descriptive question also you can expect. I think here A, B, C and D are there. The final only they are asking. Aniline in a set of reactions yield a product D. So you need to identify the D. So we can start, you know that one, dear students, it's given aniline. So starting with aniline, NH2, that one reacts with, you know that one, diazotization. CN and KCN, if they are giving together also it's same. The reaction will take place to form what? Cyanide. Okay, phenyl cyanide you will be getting, cyanobenzene or phenyl cyanide. You will be getting cyanobenzene or phenyl cyanide. You know that one, any cyanide can be reduced by H2 in presence of nickel. Not only cyanide, any multiple bond containing compounds. Okay, because H2 in presence of nickel and platinum is a common reducing agent. It can use everywhere. It's not specific whether it is cyanide or amide or wherever it is double bond, triple bond, everywhere we will be using that one. Then you know that one, you will be getting the compound. Here I will write the product. That product formed will be, here it will be both. You will be getting CH2NH2, because already I gave in the previous one, if you are using lithium aluminum hydrate, cyanide will give primary amine. Same only here it will be getting, you will be getting CH3NH2. Okay, keep in mind I wrote over there CH2NH2, that is benzylamine. It's not over because this is A and this is B and this is C. The last part you have to take care while doing that one, because that benzylamine is not an aromatic one. Dear students, keep in mind, it's an aliphatic amine. How many of you got the right answer? Hello, let me know. Chris gave the right one. Well done, well done. Sanjay, I think very good in organic part. Okay, so listen, CH2NH2, you know that one, this is aliphatic. Aliphatic amines when reacts with HNO2. Dear students, HNO2 is nothing but it's same only. NaNO2/HCl is nothing but HNO2 at 0 degrees Celsius. You know that one. Aliphatic amines when undergo diazotization, you will be getting corresponding alcohol. NH2 group you substitute and you put an OH. So corresponding primary alcohol is formed. Keep in mind, should not make mistake. This is an aliphatic amine. So NH2 will be substituted by OH. So you will be getting, you know that one, this is a alcohol, primary alcohol you will be getting. So that is given C6H5CH2OH. You know that one, this is called benzyl alcohol. Sometimes even name they can give. So this is benzyl alcohol, very important one, keep in mind. So we have the formula C6H5CH2OH. Well done dear students. Yes, Imran. Yes, good. Correct option is A. Okay, benzyl alcohol. So should not make mistake. Hope you are going to do the best one this time. All you will score the complete mark from MCQs and assertion reason. Should not make mistake. Okay, so question number 8. So take the 8th one. What is the 8th one? 8th one, the correct order of, another easy one, correct order of increasing basic nature for the bases, increasing order of basic nature for the bases NH3, CH3, NH2 and CH3 twice NH. You know that one, ammonia given, primary amine given and secondary amines given. Say they did not specify the phase, which means you know that one, normally we will be taking what? Gas phase. In gas phase, what is the order? Tertiary greater than, secondary greater than primary. This is what we called as aliphatic amines. After that ammonia comes, after that aromatic amine, okay, RNH2. This order always you keep in mind. The decreasing order only I wrote. Here they are asking increasing, I wrote the decreasing one. Gas phase, this order always you keep in mind. So here they gave the secondary. So you know that one, this is the secondary amine. And you know that one, this is the primary amine. And this is the ammonia. So which is the most among this one? Secondary greater than. So increasing order means what you need to do is you should write the secondary. So we have CH3 twice NH as the most among the given. Then the primary will come, CH3 NH2 will come. Okay, CH3 NH2 will come primary. After that the least one is ammonia. I think the correct option is D, NH3 less than this one, this one. So the easy one, yes, fossil. Yes, all are there. So right answer is which one? Option D. Dear students, send your right answer. Yes, roaring the third. Yeah, hi. So all are there. So send your right answer. This is the correct one, because this gas phase order of basicity always you keep in mind. Move on to the next one. Okay, now listen, we can go to the 9th one. 9th one is another reaction. You know that one, for the complete the reaction and all. You know that one, this question, it has been asked many times. Oxidation of aniline with K2Cr2O7 and H2SO4. You know that one. Here they can give in two ways. Aniline, okay. Aniline when reacts with this one, K2Cr2, okay, K2Cr2O7 or Na2Cr2O7, potassium dichromate or sodium dichromate, normally potassium dichromate and H2SO4. And keep in mind, sometimes they can give the same one as H2Cr2O7. Don't get confused. It's a combination of this one, same only, H2Cr2O7. It's called chromic acid. Okay, chromic acid. It's same only. Na2Cr2O7 / H2SO4 or K2Cr2O7 / H2SO4 or H2Cr2O7, if they are giving, it's all same, keep in mind. Then you will be getting a diketone. You know that one, diketone means a compound having two C double bond of functional group. Now the valency has gone, here only the valency will come. This is the diketone called benzoquinone. This para position has one more CO, that is called, it's called para benzoquinone. Benzoquinone. It's an important one. Benzoquinone will be forming. Yes, Atul Matthew, correct. Yes, Sanjay, yes, well done. All are there. Yes, Shiny Sabu, good. So correct answer is which one? Correct answer is para-benzoquinone. Okay, para-benzoquinone. So based on the basic idea, concept only, almost all MCQ and that assertion reason will come, that you keep in mind. Question number 10. So the 10th question is, yes, read the question. The compound obtained by heating a mixture of ethylamine and chloroform with ethanolic potassium hydroxide. Ethanolic potassium hydroxide, nothing but it's alcoholic KOH. So whenever an primary amine, see guys, there's an indirect question for which one? Carbylamine reaction. Carbylamine reactions are otherwise called isocyanide reaction. isocyanide reaction. So carbylamine reaction or isocyanide reaction, you know that one, all primary amine, okay, RNH2. Whether it is aromatic or aliphatic, all primary amine when reacts with the chloroform and KOH alcoholic, ALC, you know that one, alcoholic, you will be getting RNC, a foul smelling isocyanide will be forming. So it's a distinguished reaction as well to distinguish primary amines from other amines. Okay, if they are asking to distinguish a primary amine from any other compound, you can use this one. So only primary amine give this foul smelling isocyanide when it reacts with the chloroform and alcoholic KOH. So KCl plus H2O are the byproduct. That is no need to remember. This one you keep in mind. The compound obtained by heating a mixture of ethylamine, not only ethylamine, any primary amine. So here they are asking about CH3, CH2, NH2, ethylamine. When reacts with the CHCl3 plus KOH alcoholic, you know that one, you will be getting CH3 CH2 NC, okay, ethyl isocyanide plus KCl plus H2O. So this is the reaction you will be getting. So correct answer is which one? Dear students, only one isocyanide they gave. Again, what is the isocyanide? An ethyl isocyanide. This is the formula, ethyl isocyanide, okay, EIC, ethyl isocyanate. So we will be getting that one. Question number 11. Hope you understood all this one. Okay, we can finish all. Yes, all gave the correct one. Sanchay, yes, correct, ethyl isocyanate. Well done, well done. Yes, yes, roaring Rathod, hi and thank you. So question number 11. Question number 11, the gas evolved when methyl, yeah. And dear students, keep in mind this question, okay. So we are learning this one, aliphatic amines when reacts with the nitrous acid, you will be getting primary alcohol and along with that one, nitrogen gas will be liberated. That way even we can identify aliphatic amines, keep in mind, nitrogen gas will be liberated whenever aliphatic amines reacts with the nitrous acid. The gas evolved when methylamine, okay, all you keep in mind, RNH2 when reacts, an aliphatic amine when reacts with NaNO2/HCl at 0 degrees Celsius, you will be getting corresponding alcohol and this nitrogen leaves as nitrogen gas and H2 also will be formed. This nitrogen in gas forms, N2 gas will be forming, that even we can be identified or can be used as a distinguish between aliphatic amines and aromatic amines. So nitrogen gas will be evolved. So the gas evolve when, so any amines if you take, okay, CH3NH2 aliphatic amine when reacts with NaNO2/HCl at 0 degrees Celsius, you will be getting corresponding alcohol. Methanol you will be getting, nitrogen gas is liberated and water is the byproduct. So keep in mind, so correct answer is nitrogen gas. So it's a base level question only, but keep in mind that gas, you keep in mind it's a part of syllabus. We have nitrous acid test. Okay, nitrous acid test can be used to distinguish between aromatic amines, okay, and aliphatic amines. Aromatic amines, you know that one, stable benzene diazonium chloride is formed, but aliphatic amine will give corresponding primary alcohol. That you keep in mind. Yes, dear students, all are there, right? Sanjay, very good, very good. We did this one in the competitive exam level question, we did this one minimum, but few question you have to keep in mind, it's a part of syllabus only, 1 or 2 question they can put it as a bit hard, but you should be able to answer it. That's why we are keeping that type of question. So keep in mind, we will move to the question number 12. See, 12th one is, which among the following amine has the highest basic strength in aqueous solution? So in basic strength in gas phase, already we included one question and we did this one, and we know the order of basicity. Now I selected one question for basic strength in aqueous solution. You know that one in aqueous solution, okay, in aqueous solution what is the order? You remember, right? In aqueous solution we have the order of basicity, that is secondary greater than primary greater than tertiary. Okay, this is mainly for CH3 alkyl group. This most of the case it is the CH3 only came, but you know that one, if C2H5 group is coming, this will, you can flip the order, the second and the third one. Then you know that one, it will be secondary greater than tertiary greater than primary for which group? C2H5. Even this is the part of syllabus, but don't try to remember both, it may get confused. Better you remember only the one. I used to tell the students to remember like this one, SPT. Okay, that you keep in mind. Secondary, primary and tertiary, that you keep in mind. For which one? In aqueous solution, SPT you keep in mind. That is for alkyl, means methyl group, methyl group. So whenever it ethyl comes, that PT you flip it. Okay, that PT if you are flipping, you will get the order for C2H5, but don't try to memorize both, it may get confused. So better you keep in mind that SPT, that would be easy. Okay, so now we can write this one. So here it's the secondary, it's the easy one, because in aqueous solution, three factors, okay, the criteria which determines the basicity in aqueous solution are which one? Inductive effect or plus effect. Next is steric effect. Third one, hydration enthalpy. These three average order when you take, that order is this one, tertiary, secondary greater than primary, tertiary. That SPT you keep in mind. So correct answer is option C, correct? C2H5 twice NH. Whether it is C2H5 or CH3, that secondary one is same, no doubt. So I think almost all gave the right one. Yes, yeah, shiny sabu, that you keep in mind. C2H5 means that will be the coming one, and CH3 means secondary greater than, primary greater than, tertiary will come. That SPT you keep in mind. Yes, yes, that you can keep in mind. Okay, so right answer is option C for the 12th one. Okay, now we will move to the next one. Yeah, 12, almost 12 questions. 12 questions we did from the chapter Amines. Now we will, the remaining question we are going to do from D and F. Okay, so the inorganic chapter D and F. Shall we start? Are you ready? D and F chapter is the favorite chapter for you guys, right? Yes, Sanal. Hi. Yes, that chapter is. Hello. That D and F is the favorite chapter for you. Let's see the reply. Okay. Yes, Ola there. Atul, yeah. Yes, CR, what happened? That D and F you are not confident? See, D and F you can easily score the mark. All the questions will be same. We have done one same, I think the last board exam. One live session is there in our YouTube channel. You can go through that one. Almost all questions will be coming as same. So you can go through that one. Yes, Atul. Yes, you can easily score the mark. Okay, from D and F. Let's see. So we will do the question. See, question number 13. Read the question. Yes, question number 13. The pair that has similar atomic radii. The pair that has similar atomic radii. The pair that has similar atomic radii, which is the correct answer. Do you have any hint about this one? Rohan George. Yes, Rohan Jiku. Yes, Satvik. Satvik, you have to revise the chapter and do the previous year question only. That only will come. That is the highlight of the chapter. Okay, every time the questions will be last 7 or 8 years question you take, it will be same. You can easily score mark. Flip-flops. Yes, see the question, the pair that has similar atomic radii, you know this question is based on the concept. What? Tell the concept. It is lanthanide contraction. See guys, what is lanthanide contraction? The atomic radii, there is a regular decrease in atomic radii or size from lanthanum to lutetium. Okay, or cerium to lutetium due to poor shielding effect of 4f electrons. So 4f electrons are getting poor shielding effect. So there will be stronger attraction from the nucleus and the size will be keep on decreasing. This is called lanthanide contraction. Lanthanide contraction has two consequences. The first one, similar atomic radii of 4D and 5D series. So 4D and 5D series has similar atomic radii, and 3 examples are given in the textbook, which all, you know that one. First one is zirconium and hafnium. Okay, zirconium just below hafnium comes, they have similar size. After that, niobium and tantalum, Nb and Ta. After that, molybdenum and tungsten, Mo and W. This one always you keep in mind. These all has similar size. These 6 has similar atomic radii or similar size and almost same property because of lanthanide contraction. What is the second consequence? Second consequence, you know that one, lanthanum hydroxide, LaOH thrice to LuOH thrice, lutetium hydroxide, basic character decreases. Okay, basic character decreases, you keep in mind, because size reduces means the lutetium OH bond will be the strongest bond and OH will not be will not come out when the bond means it is very difficult to break the bond. Hope you got the idea. That bond will be stronger means it cannot produce OH minus ion, but lanthanum hydroxide can produce easily the OH minus ion, so it's more basic. This is the least basic. Just I gave the additional point based on the lanthanide contraction. You keep in mind here the pair that has similar atomic radii, among these 3 you have to choose one. Which one is given? Zirconium, hafnium, niobium, tantalum, molybdenum and tungsten. Molybdenum and tungsten is given. Hope you got. Yes, Ansh. LuOH thrice bond, Lu, because here size is what? Smaller. OH has similar size, no? Lanthanum and OH. Here OH has the same size, but here lanthanum is the large, so here the bond length will be longer. Here Lu is the small. Small means the atom will be very close to OH and the bond will be shorter. Shorter bonds are stronger. Hope you understood. Yes. Now we will move on to the next one. Correct option is D. Ansh, you got the idea, right? Yes. Yes, okay. So we will move to the 14th one. Question number 14. 14th one is, although +3 is the characteristic oxidation state of lanthanoids, but cerium also shows +4. Keep in mind, guys, there is few exception in case of oxidation state. That few exception, one is in case of cerium and one more is there in +4. What is the common oxidation state of lanthanides or lanthanoids? Lanthanoids, the common oxidation state is +3. Okay, but cerium and terbium, keep in mind, both exhibit +4. But in aqueous solution it comes from +4 to +3, but in aqueous solution it will be more stable, because what is the general electronic configuration of cerium? Cerium will be xenon. After xenon it is 54. You know that one, 4f1, it is the first element of lanthanoid, so 4f1, 5d1 and 6s2. This is the electronic configuration of cerium. Don't try to memorize the electronic configuration of all elements. Few elements are important: gadolinium, terbium, cerium, europium. Okay, that all you keep in mind. Remaining all, it's not that important. So cerium +4. Why +4? +4 means you remove 4 electron. All the 4 electron when you are removing, you know that one xenon is the electronic configuration with the 4f0. Xenon with the 4f0 is stable because xenon electronic configuration is very stable. Same like terbium. Terbium, you keep in mind, it's the 8th element actually. Xenon with the 4f8. Okay, 5d0, that it will be, you know that one, 4f8, 5d1 and 6s2. It will be like this one. So if you are if it removes 4, you know that one, what will be getting? Xenon with 4f7. 4f7 is also stable, half filled. Remaining, I am not writing that 4f7 and 4f0 means stable. That you keep in mind. Cerium and terbium are exception. That exception you keep in mind. One question they may ask based on this one. Yes, Sanjay, flip-flops, correct. Satvik, correct. Ansh, yes, well done, well done. So here the correct option is which one, dear students? The correct option is which one? Tendency to attain 4f0 configuration is given. No variable and annexation dalpi P4 PB4 plus, no. Different one. Greater lanthanoid contraction, no. Correct answer is 4f0. If they are asking for terbium, I gave the additional one. Terbium means 4f7. That also they asked. That's why I gave. Yes, Venkat. Yes, C is the correct one. Well done, Venkat. Good. So correct answer is C. So these two you keep in mind for +4. Common oxidation state is +3. So from +4 it readily turns to +3 in aqueous solution. That you keep in mind. Now we will move on to the question number 15. Next one. Which one of the following is diamagnetic ion? I think while reading this one, you will get the idea. Cobalt 2 plus, Ni 2 plus, U 2 plus and Zn 2 plus. Can you give the answer, dear students? Yes, all are there, right? Give the right answer. Give the right answer. Hello. Yes, dear students, give the right answer. Here they are asking about the which one? Diamagnetic means no unpaired electron, right? So no unpaired electron means we learned in case of zinc, both in ground as well as in die positive state. Yes, all are giving the right answer. Well done. Yes, all are giving. Zinc is a pseudo transition element because of the reason. What is that? What is the reason? Zinc has unpaired zinc has completely filled D both in ground as well as in die positive. So zinc 2 plus, what is the electronic configuration? I'll write argon with 3d10 4s0. Even if it is Zn also, 4s will be 2. Now 3d10 means no unpaired electron. No unpaired electron means diamagnetic. So right answer is zinc. So we will move to the next one. Okay, yes. Now question number 16. See, 16th one is color of transition metal ions are due to absorption of some wavelength. This results. We know that one. Why transition elements exhibit color? We know that one, transition elements, if there is unpaired electron from T to G, from T to G electrons are get excited into Eg. So excitation of electron require energy. It absorbs energy from, yes, light, visible light. A particular wavelength of light will be absorbed to excite the electron. And while coming back, the excited electron when comes back, absorbed energy will be emitted in the form of, yes, absorbed energy will be emitted in the form of electromagnetic radiation, means light. So a complementary color will be emitted, dear students. That complementary color and all we can, yes, correct answer is DD transition. T to G to Eg, that transition is called. Wherever unpaired electrons are there, unpaired electrons means it undergo DD transition. So correct answer is which one? DD transition. So no, I think explanation is enough. Unpaired electron and DD transition, that you keep in mind wherever they are asking about color. So unpaired electrons are there and DD transition, that is the right answer for color. Shall we move to the 17th one? Read the question. Question number 17. What is the 17th one? Question number 17. The melting point of copper is higher than that of zinc. You know that one? We have a statement. All transition elements have high melting and boiling point. All transition elements have high melting and boiling point except few elements. So generally we can make a statement, all transition elements have high melting and boiling point because they form strong metal-metal bonding. How they form metal-metal bonding? The neighboring metal atoms of transition elements form strong metal-metal bond due to the presence of unpaired electrons in the d subshell. So unpaired electrons are there in the d subshell. So for neighboring atom, they can form metal-metal bond, or that unpaired electron become paired and they form the metal-metal bond. So that is the basis for the hardness, even the melting point, boiling point, all this is due to the strong metal-metal bond formation. Yes, very good. All are there. Well done, Venkat, Karthik, Ansh, yes, all gave the right answer, but don't get confused here. I think it's a previous year question. Copper has, that is different basis structure, no, that all we had one chapter that is deleted. The atomic volume of copper, no, the electrons of copper are involved in metal bonding, correct. The S as well as D electrons, no chance of S undergoing metal-metal bond, no, only D will be undergoing metal-metal bonding. So correct option is C. So only the unpaired electrons in the D subshell undergo metal-metal bonding. By the neighboring means the neighboring atoms of metal will undergo DD. Yes, correct answer is very good. Hisham, Venkat, Sanjay. Right answer is option C. That always you keep in mind. Wherever high melting point, okay, high boiling point, hardness, all these 2 points you keep in mind. Unpaired electrons, okay, unpaired electrons in D subshell and strong metal-metal bond, okay, strong MM bond. That is the reason for melting point, boiling point, hardness, even enthalpy of atomization, okay, atomization enthalpy. For atomization enthalpy also, this is the same reason, keep in mind. So all this is the reason for all these 4, and enthalpy atomization, melting point, boiling point, hardness. Question number 18. Read the question. Question number 18. In the dichromate ion, see we have ion, dichromate, chromate, manganate, permanganate. That 4 ion structure you keep in mind. One question I put, Okay, you have to give focus on the structure of ion. So here the dichromate ion means, you know that one, the orange red color, that the dichromate ion. What is the dichromate ion? Cr2O7 2 minus. How do you draw the structure of Cr2O7 2 minus? You know that one, Cr, okay, one oxygen over here. Due to resonance, I am drawing with the single bond, and here it is the peroxide linkage will be there. One Cr and this one Cr, again oxygen, again oxygen, again oxygen. That the tetrahedral, two tetrahedral unit will be combining to form 2 minus. This is the structure of Cr2O7 2 minus, and you keep in mind in this one, these all oxygen, these three oxygen, this one, this one, this one, this one, this one. Due to resonance, their bond length will be same. Due to resonance, their bond length will be same. That you keep in mind. So which all bonds are same? Which all bonds are same? The 6 chromium oxygen bond, these three and these three. This will not be same, you know that one. It's a here only resonance happens. Then you know that one. These 6 chromium oxygen bonds are equivalent. That you keep in mind. It's an question. B is the correct answer. Well done, well done. Yes, yes. Where is Hisham, Sanjay, Ansh? What happened? Yes. Shiny, Sabu, well done, well done. Yeah, correct. Yes, Imran, good, good. Yeah, good. Yeah, Ansh, you should understand this one. The structure we learned, it's important. All the structures are there in the note that you have to prepare. Yes, Shyam Kumar, Hisham, yes. So that you keep in mind. Okay, correct answer is option B. Shall we move on to the next one? Question number 19. Take the 19th one. Yes, Ansh. Yes, so 19th one is magnetic moment of 2.83 Bohr magneton is given by which of the following ion? See, here we discussed the question in this chapter, you know that one, spin only magnetic moment mu is equal to root of n into n plus 2. Bohr magneton is the unit. This is the equation to find out the spin only magnetic moment means magnetic moment of an ion, atom or metal ion. So by using this equation you can find out where n represent the number of unpaired electron. So n is the unpaired electron. So here I think you know that they are giving 2.82. 2.82 is I think approximately root 8, right? Root 8 will be 2.83. Hope it is correct. Yes. Now we can, so 2.83 will be root 8. Root 8 means you know that one, what n value should come? N value, I think n value should be 2, right? 2, yeah, correct, right? 2. N equal to 2, so 2 plus 2 will be 4. 4 into 2 become 8, yeah, correct. So what is Ni? I think the correct answer will be Ni2 plus. Let me check. Ni2 plus electronic configuration will be argon with 3d8 4s0. Because nickel is 28, it is 3d8 4s2. So 2 plus means 3d8. 3d8 means you know that one, D has 1, 2, 3, 4, 5. This question also they are repeatedly asked, so we can directly go actually. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, correct. N equal to 2. N equal to 2 means when you substitute into the mu equation, mu is equal to root of 2 into 2 plus 2, 4. Okay, so 2 into 4, 8. Root 8 is equal to 2.83, correct? Sanjay, it's correct, right? Yeah, root 8 is equal to 2.83. Yes, yes, correct. So, answer is B, Ni2 plus. Yes. Right answer is, whenever you are getting n equal to 2, then it will be root 8. Root 8 will be 2.83. Right answer is B. Okay, shall we move to the next one? Question number 20. See, question number 20 is, which of the following is a wrong statement? That assertion, reason type and this type of question will be coming. Yes, Jamshid. Yeah, which of the following is a wrong statement? See, this one already I gave an idea. The question is based on, I think, lanthanide contraction. Lanthanum hydroxide is less basic. Wrong. That is, we discussed already. Lanthanum hydroxide is on the leftmost side. That is the most basic. When we move on to the right side, basic property decreases due to lanthanide contraction. First statement itself is wrong. They are asking wrong only. Which statement is wrong? In lanthanoid series, ionic radius decreases from lanthanum to lutetium, correct? Ionic radius decreases from lanthanum to lutetium. That is called lanthanide contraction, correct? Zirconium and hafnium exhibit almost similar properties due to size. Correct. Transition metals exhibit variable oxide state. Correct statement. So which is the wrong one? Yeah, correct. Yeah. Answer came already. The correct answer is lanthanum hydroxide is less basic. No. Among those hydrides of lanthanoids element, among the lanthanoid element, lanthanum hydroxide is the most basic and the least basic is lutetium hydroxide. Keep in mind. Yes, Sanjay, well done. Very good. Yes, A is the wrong statement and that's the correct answer. Yes, well done, well done. Yes. Question number 21. We can finish the questions. Question number 21. Maximum oxidation number exhibited by. See, this is the syllabus part. We have to keep in mind two things about oxidation number. So many questions are there based on element. You know that one in the 3D series where it starts scantium to zinc. Which element exhibit maximum oxidation state Mn and the highest is what? +7. Don't get confused among the 3D series. But among all transition elements, okay, among all transition element, the element which exhibit maximum oxidation state is osmium, OS. What is the oxidation state? +8. That you keep in mind. Osmium is the element which exhibit the maximum oxidation state, that is +8. I think, yeah, Karthik, Sanjay, Ansh, well done. Yes, Venkat. Yes, good. Imran, Atul, Matthew, Abraham, very good, very good. Question number 21, right answer is +8. Question number 22, yes. See, this is I told already. There are few elements. Its oxidation number, you have to keep in mind that oxidation number is, I told you, cerium important. Okay, terbium important, europium important, GD, gadolinium is important. So what is the, see, no need to remember the name, dear students, even though it is two way you can remember, I'll give the both. GD is the, keep in mind, it's the 7th element of the lanthanoid. 7th element means cerium is the first one, 7th. Why I am giving like that 7th one? Because you can remember like this one, xenon, then you write 4 of 7, okay, 5D1 and 6S2. 7th element means this way you remember, and terbium was the 8th element. That is what I told you, TB. 8th element means you can remember like this one, 4 of 8, 5D1, 6S2. 8th element is terbium. And otherwise you can remember like this one, you know that one, xenon is 54. Okay, 54, after that 4 of comes 5D and 6S. Okay, 6S. You know that one, here 54 is over. Okay, then you know that one, you have to add 10. So 10 you have to add means, you know that one, here anyway will be 2. Here due to half-filled stability, here it will be 7. 7 plus 2, 9 means 1 will be coming 1. So 54 plus 10, 64. That way also you can remember, terbium is the 8th element. That's why writing like this one. This is the 7th element. That will be the easy one that you keep in mind. So correct answer, I think this one, A. 4 of 7, 5D1 and 6S2. Hope you understood. Okay, this one is the right one. Now I'll move on to the 23rd. Yes, Sanj, correct. Atul, Matthew, right one, right one. This one you keep in mind, gadolinium and terbium. Question number 23. Transition metal form complex compound because they have, you know that one, all transition element except pseudo transition element, they can form complex compound because of their high positive charge, small size and availability of vacant d orbital. That 3 points we learned. Yes, Shasa. So we know that one, transition elements have high positive charge, they have vacant d orbital, and you know that one, they have small size. So small size, right one, high nuclear charge, which means high positive charge only. Okay, high positive charge. Then you know that one, after that what they give, high positive charge, after that a number of vacant orbital. Yes, all these are the right ones. So correct answer is option D. Yes, I think yes, all of these. Sanjay, very good. Atul, Venkat, good. Hisham, Sanj, and Naina, Dia. Now all are there, I think. Well done. Ansh. Yes, so for D and F, can you tell which all elements? Yeah, Ansh, these all elements you keep in mind: cerium, terbium, gadolinium, europium. Okay, that all elements, exception. It's there, everything in the note, that exception things that you keep in mind. That only they will be asking normally. Okay, promethium, artificial element. That you keep in mind. That only they will be promethium and all. No need to remember the atomic number. Artificial element, that you keep in mind. Question number 24. Question number 24. Listen, dear students. Which of the following characteristics of transition element is associated with the catalytic activity? 2 points. We know that one. Transition elements act as very good catalyst due to 2 points. First one, they helps to form reaction intermediate due to variable oxidation state. Second one, they provide surface area for adsorption of gases or adsorption of reactants easily. Reactants can be easily adsorbed on the surface of catalyst. So variable oxidation state, paramagnetic nature, color of hydrated ion, high enthalpy of atomization. As I told you, due to variable oxidation state, they can form reaction intermediate very easily. Okay, reaction intermediate will be forming very easily. That way they can accelerate the reaction. So that is the right answer. So we will move on to the next one. I think 2 more questions we have. We will be finishing. So variable oxidation state is the one important. Second one, they provide surface area for adsorption. That you keep in mind. That is the second point. Question number 25. Question number 25. The statement that is incorrect for the interstitial compound. Dear students, what are interstitial? In case of transition element, whenever transition elements form compounds, there will be some gap in the between the atoms, that is called interstitial site. In the interstitial site, they can absorb gases like nitrogen, hydrogen and small elements like a carbon. These, when occluded or trapped into the interstitial site, such compounds are called interstitial compound. Interstitial compounds are very hard. They are non-reactive. Correct. They have high melting and boiling point and they are good electrical conductors. So they have many applications. So they are inert, they are electrical conductors, they have high melting and boiling point. Okay, that all you have to keep in mind. So they have high melting and boiling point, correct. They are chemically inert. They are chemically active means it's wrong. That is the right answer because they are telling what is the incorrect. They are chemically inert. Always you keep in mind interstitial compounds are will not react with any compounds or substances. They have metallic conductivity. Correct. They are conductors. They are very hard. Yes, they are very hard. So hope you got. Yes, wrong one is they are chemically reactive. That is wrong. They are chemically inactive and that have some benefits, economical benefit because of that property. I think this will be the last one. So question number, this last question we will be doing. Listen dear students. This one, which has half filled 4F. See, this is what I told you, that cerium, terbium, that all they will be asking. I told already that terbium and terbium you keep in mind. What about terbium? Terbium, you know that one is the 8th element, so you will be getting xenon, then 4F8. Okay, this will be, which will be plus 4, yeah, 4F8 and 5D1 and 6S2. Okay, then what will be TB plus 4? TB plus 4 will be xenon, 4F7, 5D0, 6S0. See, this will be 4F7, important. So it's there in the note that half filled and this one 4F0 cerium, this one 4F7 and europium also you have to keep in mind. That is another exception. Okay, even that gadolinium can also form GD. GD, you know that one is the 7th element I told you. So xenon, okay, 4F7, 5D1 and 6S2. So that already 7 and even in 3 plus also it will be stable because it will be 4F7. That you keep in mind. These few elements only you have to keep in mind. So which one is having this one? GD is given. Okay, but GD is not in plus 4, it is in ground state. Keep in mind they are asking about plus 4. So plus 4 oxide state, which is the half filled, that is terbium. Terbium is in. Yes, A is the right answer, that is terbium. Correct, terbium is the right one. Okay, so I think all the questions we finished. Yes, so today's questions are over. And dear students, do a very serious preparation. Okay, this is the last time, and prepare a timetable accordingly. Should not waste even a second and prepare very seriously and practice all the questions. Any support if you need, we will be giving you, and we will come back after your first exam, English exam. Again, one more live will be there and see you there. Thank you so much for watching and thank you for the support. See you next time. Bye bye. Thank you.